Let f of x be equal to 2x minus 7 and g of x equal to 3x squared minus 8. Given these two functions, find and simplify the following and state the domain. In each sub-question here, we are going to create a new function given the two functions f of x and g of x. And then after we simplify what that new function is, we'll state the domain. In part A, we want to create the function f plus g of x. So the definition of this function is the addition of our two functions, f of x plus g of x. F of x is the 2x minus 7. So to that, we're going to add g of x, and g of x is the 3x squared minus 8. Now we have the simplification process, where we are trying to identify like terms. Because this is a polynomial, I'll go ahead and list the terms in decreasing degree or decreasing order. So the 3x squared has the highest degree here. So the 3x squared I'm going to write first, and there's nothing else that has an x squared, so that one won't combine with anything else. 2x would be next, and that's positive. And again, there's nothing else with an x, so that'll be by itself, nothing to combine with. And finally, my constants, I have negative 7 and negative 8, both negative. If I add 7 and 8 together, I get 15, and because they're both negative, the 15 will be negative. So 3x squared plus 2x minus 15 is the new function, f plus g of x. The last thing I need to do for this function is state the domain. This function is a polynomial, which means the domain is all real numbers. I can choose any value of x that I want, and I will never have a problem plugging it into my function. Part B is very similar to Part A. We now are finding the difference between f and g. So I have f of x minus g of x. F of x is 2x minus 7. And here I'm going to subtract g of x, and I'm going to use parentheses to make sure I do that correctly. So I have 3x squared minus 8. 2x minus 7, and I'll distribute the negative. So I'll have a negative 3x squared and a positive 8. Searching for like terms and going in decreasing exponent, the negative 3x squared, I would list that one first. Which again, you don't have to do this. We typically do this though with polynomials. The 2x would be next, and that's positive. And then my constants, I have negative 7 and positive 8. So I can think of this as 8 minus 7. That's one way to think about it. So my constant would end up being positive 1. So the function f minus g of x would be defined as negative 3x squared plus 2x plus 1. Just as in part A, this function is a polynomial, which means our domain is all real numbers. We can plug in anything we want for x. Part C, another way we can create a new function is by multiplying the functions f and g. So we want to take the function f of x and multiply by the function g of x. Because both of my functions have more than one term, I'm going to use parentheses to make sure that I perform the multiplication correctly. So we just need to make sure that each term in each set of parentheses gets multiplied by every term in the other set. The 2x times the 3x squared would give me a 6x cubed because I have an x times an x squared. 2x times negative 8 would give me a negative 16x. Negative 7 times 3x squared would give me a negative 21x squared. And finally, negative 7 times negative 8 would give me positive 56. Okay. And again, because this is a polynomial, we will go ahead and list them by decreasing exponent. So we have 6x cubed minus 21x squared minus 16x plus 56. You also could have left it just as it was without the terms being in decreasing order of degree, but it's up to you. Most people typically follow the exponent when they write their final answer, but any order of the terms is correct as long as you have the correct sign. So just make sure if you rearrange them, you do pay attention to which is positive and which is negative. So this would be the definition of our function f times g of x. It is a polynomial, so our domain is all real numbers. We can plug in anything we want for x. Part D, we have the quotient of our two functions. So we have f of x divided by g of x. So f of x is in the numerator, and that was the 2x minus 7. G of x is in the denominator, that's the 3x squared minus 8. In terms of simplification, the only thing that we could do here is potentially factor out a common factor of the numerator and denominator. However, the numerator is degree 1, so we can't factor 2x minus 7 into anything interesting, so we won't be able to simplify this any further. So here we have a rational function. So the domain is not going to be as simple as it was for the previous examples where we had polynomials. For a rational function, we have to make sure that our denominator does not become 0, because if we divide by 0, we have an undefined situation. The 2x minus 7 in the numerator, that can be 0. In fact, that can be any number it wants to be. So we're not going to have any restrictions from the numerator. The only restrictions are going to come from the denominator. So we need to know, when would 3x squared minus 8 be equal to 0? Any of those solutions are going to be values that we cannot include in our domain. To figure out these values, I'm going to solve for x. I'm going to add 8 to the other side. So I would have 3x squared is equal to positive 8. Divide both sides by 3. Move up here. So we would have x squared is equal to 8 over 3. Now to solve for x, I need to take the square root of x. And when I take the square root of 8/3, there are two options. I have a positive option and I have a negative option. So I have plus or minus the square root of 8 over 3. Now, we could take this a bit further and simplify this square root. So the first step in doing that would be using the quotient rule and separating the numerator and denominator. So we'd have square root of 8 over square root of 3. Next, we would want to simplify either of the square roots if we can. So the 8 does have a factor that's a perfect square. We can view that as 4 times 2. The 3, however, there's nothing to pull out of that, so that will stay the square root of 3. So taking the square root of 4, which is 2, we have plus or minus 2 square root of 2 over the square root of 3. If we want to get really fancy here, we can rationalize this answer by multiplying by the square root of 3, top and bottom. So that would leave us with plus or minus 2 times the square root. In the numerator, we have the square root of 2 times the square root of 3. From algebra, we know that we can combine those using the product rule. So that would become the square root of 6. And in the denominator, we would have the square root of 9, which becomes 3. So this would be the most simplified rational answer that you could come up with. If you want to leave your values as you did where we started from, this is okay too. The two solutions that we have here, they are identical, so you can enter either one. Just to be formal, I'll go ahead and go with the rationalized simplified version. So there are two values that we can't use. We have the positive 2 square root of 6 over 3, and we have the negative 2 square root of 6 over 3. Those are the only two numbers that are going to cause a problem. Every other number is okay. So if we think about our domain, starting from negative infinity, the first one that we would run into is the negative. So we'd have negative 2 square root of 6 over 3. And that is going to have a curved parenthesis on it because I cannot plug that into my function. So I can get really, really close to it, but I can't use it. So I hit that value, I jump over it. So I have to use a union symbol to keep going. So right on the other side of it, again, would be just a little bit bigger than negative 2 square root of 6 over 3. But now we're on the other side, so we'll start a little bit bigger than that one. The next one that we hit is the positive option. So we would have positive 2 square root of 6 over 3. And again, we have to pause when we hit that one because we can't actually use it. So we jump over it. So now we're on the other side, 2 square root of 6 over 3. And now I can continue on without any problems. So now I can go towards positive infinity. So to describe the domain of my function, I actually have to use 3 intervals, and I use the union symbol to imply that all of these together is describing my domain. And again, it does make a difference if you're using curved parentheses or square brackets. Infinities always have a curved parenthesis, and on a value, a curved parenthesis means you can't use it, and a square bracket means that you can. So make sure you pay attention to that depending on the situation. All right, last function that we want to create is f of g of x. So this is a composition. By definition, what we want to do here is plug the function g of x into the function f of x. And the reason that I know that is because the g is closest to the variable. So it's like an onion. You have to peel back the layers, and you have to start with the one that's closest to the variable. So this means f of g of x. So we literally are going to plug in the function g into the function f. So that looks like f of, so g of x again was 3x squared minus 8. So we need to plug in 3x squared minus 8 into the function f wherever we see an x. So we have 2x minus 7. So we'll have 2 times 3x squared minus 8. And then the negative 7 does not have an x. It's just the constant negative 7, but we can't forget that. That still needs to be there. Simplifying, we can distribute the 2. We'll have a 6x squared minus 2 times negative 8, so negative 16. And the 2 is not multiplied by negative 7. That's by itself. So we still have the negative 7. So we have 6x squared, and then our two constants, negative 16 and negative 7, those would combine to give us negative 23 as our constant. So 6x squared minus 23 would be our new function f of g of x. The domain here is easy. This is a polynomial, so our domain would be all real numbers.